awesome. We're going to look at degrees in radians. And I remember learning about radians the first time and being like, this is really stupid. Why would we ever do this? And immediately learning it for the test and then throwing it away. And then it showed up again and I was like, why are they still doing this? This is dumb. And I learned it again and I threw it away. And then all of a sudden I was like, oh, wait, these matter. So just in case this is the first time you've heard about radians, you should actually pay attention because they super duper matter. Well, at least they matter if you're going to do anything in terms of sciencey, mathy stuff. So, okay, so you have a circle. This is a circle. Isn't it pretty? Okay, so we know, maybe, a circle has 360 degrees because the Babylonians had a sexagesimal system. This has nothing to do with this lecture. It's just a random reason why we have 360 degrees instead of like 100 or something. So you have a random number of degrees in a circle just because some civilization had a weird base number system, okay? There's really no reason for it. It's totally arbitrary, just like the number of hours in a day or the number of seconds on a clock or, you know, how many calories are in a quart of milk or something. No, that's probably a real number. How many feet are in a mile? There you go. That's the kind of thing. Okay, so random numbers has nothing to do with science. Okay, now, so we know a quarter of circle has 90. So if I was gonna just look at this little quarter here, that would be 90. If I'm looking at the whole thing, sorry, just half the thing, that'd be 180. If I'm looking at just that part, all the way, look at these amazing animations. I'm kind of an animation genius when it comes to PowerPoint. 270 degrees, and if we go all the way around the circle, that's the full 360 degrees, okay? Got it? Got it. Okay, now, there's another way to think about this. We can think that if we had a circle that had a radius, come here, pen, come on, pen, don't fail me now. If it had a radius of 1, that the circumference, remember a circumference of a circle is 2 pi r. So in this case, it would be 2 pi times 1 or just 2 pi. Well, that's where the whole like 2 pi radians comes in. So if you've ever wondered, why did you just arbitrarily pick 2 pi radians? We didn't arbitrarily pick 2 pi radians, the universe did. So yeah, like this 360 degrees is a pretty number, but it's actually completely arbitrary, and the degrees is like a unit of measurement. So this is really weird. This also doesn't have anything to do with specifically what we're doing now. This is a unit of measurement. I can't spell. 2 pi radians are considered unitless. Like, it's weird. So if you list something in radians and then you do something to it, it doesn't have any like degrees or radians. I don't know how to describe it. Like, we'll say radians to remind you it's radians, but technically radians isn't a unit, it's unitless, because this one just goes out into the ether. Because that one could have been anything. I feel like we're getting into philosophy now. But the 2 pi radians, the whole point is the 2 pi radians actually refers to what the entire circumference of that circle would have been if it had had a radius of 1, its entire circumference would have been 2 pi. So 360 degrees is 2 pi radians. Isn't that great? So similarly, if the whole thing was 2 pi radians, then only a fourth of it would be 2 pi over 4, or pi over 2 radians. So 90 degrees is pi over 2 radians. Half of the circle would be half of pi over 2, which would be pi radians. And again, we're saying radians to remind ourselves that it's in radians. Technically, we should be saying 100. Now, we usually do the opposite where we say, oh yeah, the angle's 180, and then we say, but it's really pi radians. In theory, we should be saying it's 180 degrees, but it's just pi, because the degrees are the actual units that are real units, and then the radians are like non-units. Anyway, again, this is more of math philosophy, which I never got to take. It was super sad. Not that anyone ever offered it to me, but I would have taken it. So we're going 3/4 the way around the circle, or 3/4. Yes, 3/4 the way around the circle. I'm going to work that out. 3/4 the way around the circle times 2 pi is 3, and so the 2 goes away. 3/2 pi. Does that make sense? 3/4 the way around the circle, 3 pi over 2 radians. Another way you could think about it is, you could think about it like I go pi radians, and then I go another pi over 2 radians, so that's 3 pi over 2 total radians. Okay, so the thing was, so you memorize, this is where the numbers come from. When it comes down to it, you basically just memorize it. I had a high school teacher who told us to make degrees into radians, I forgot my little degree symbol here. Oh my goodness, that's so embarrassing. Okay. To make degrees into radians, you want to multiply by pi over 180. So my teacher told me that if you see something that's like written like 2 pi and you want to turn it into degrees, she was like, well, you want to get rid of the pi. But you don't really want to get rid of the pi. That's not really why. It's because you want to turn it into degrees. So just like with unit conversions, it doesn't have any units. You want to get rid of the fact that it doesn't have units and turn it into units. It's not that you're getting rid of the pi. Because to be honest, the number 7.4 could be a number in radians. And if you're trying to say, well, I want to get rid of the pi, but there's no pi there because it's already been multiplied into the system, what you're really looking at is if I have 7.4 radians, it's 180 degrees divided by pi. And if it just helps to write down this radians thing, that's fine. Radians cancel out, and then whatever that is, you get as an answer. I guess I should have actually worked this out before doing it. I have a calculator somewhere on my phone. 180 times 7.4 is, holy Gemalama, that's a lot of degrees. 1332? Oh, wait, I forgot to divide by pi. That's why. Pi divided by, oh, there you go, 423. That makes more sense. So this is 423 degrees, which kind of makes sense if you think about it, because this is kind of like a little over 2 pi plus extra. So I've gone around the circle once, which is 360 plus a little extra. So that kind of makes sense. But yeah, basically to make degrees into radians, if I have 32 degrees, I want to get rid of the degrees. So the degrees go on the bottom and the pi goes on the top again. I'm not trying to get rid of the pi. Now, a lot of times you'll have homeworks and whatever that will say, leave your answer in terms of pi. So it might want you to be like 16 pi over 90 or something like that. And I don't really know why they would do that, but sometimes they will. 16 pi over 90. Oh, math is, I'm not paying attention. Or approximately 55.55 radians. Does that make sense? Hold on, let me redo that. So I have 32 pi times 180 divided, yeah, okay. So it's about 55 radians. 55, 9-ish. But anyway, all that said, this is how you do it. Whenever you're doing a basic conversion, this is the work, but a lot of times they'll have you leave it like this. And usually whenever you're doing the other direction, they'll give it to you in terms of pi. My high school teacher wasn't totally wrong for the purposes of high school trig problems. Okay, so pause the video, see if you can work through some of these and get some values. So I will give you a second to do that. Okay, so 45. So in case you just didn't remember from before, we could be like pi over 180. We're going to leave these in terms of pi. And if you have a hard time simplifying, instead of doing 45 divided by 180 on your calculator, you can do 180 divided by 45, and that'll get you, so if you do 180 divided by 45, that'll give you the 4 so that you know it's 1/4. Just a little trick. Times pi over 180, and then I've got 15, I feel like this is hard to read. I should have changed colors ages ago. I can get rid of that. And then divided by 5 on the top is 3 pi, and divided by 3 on the bottom is, wait, am I terrible at math? Divided by 3 is, yes, I am terrible at math. This is why nobody should ever listen to me. I'm going to rewrite this because I think I changed colors and freaked myself out. Okay, so times pi over 180. So if I divide by, this is the part that scares me, 5 pi over 6. I know the answer is 5 pi over 6 because I have it memorized, which is what I'm going to tell you in a minute. But I'm just saying, I was trying to do it by hand to show you that it was possible. Okay, and then do, and then, dang it, I don't know how to reduce that in my head. I'm going to try to, 135 divided by something, 45 is 3. And then 180 divided by 45 is 4. Yes, 3/4 pi. So I divided by 45 there in case you were wondering. And then times pi over 180 here is going to give me 18 over 30 is 6. So pi over 6. Okay. And I just knew that was pi over 6, but that's okay. Okay, so I've got those going one direction. And now I can go the other direction. Again, we're not dividing by pi to get rid of the pi. We're trying to get the degrees. The pi's do cancel out though. So, pshaw. 30 degrees. Almost wrote pi degrees. So then we've got, I wrote it upside down. I'm too busy thinking about soup. All right, 180 degrees over pi. The pi's go away. And 180 divided by 4 is something, right? In theory. I mean, I know the answer is like probably on the other side. 45 times 3 is 135. Yeah, it's like literally I already did this one, but that's okay. We're just doing it to show that we know how. Times 180 over pi. Pachonk, 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 pachonk. 60 is 120. Okay, so that's how you do those. Either multiplying by pi over 180 to turn into radians, or multiply by 180 over pi to turn into degrees. Now, that said, when I was saying I've got most of these memorized, it's because I've been doing this a while. These are the ones you want to have memorized at the very, very, very minimum. Now, I didn't put on here that 0 degrees is 0 radians, in case that was not clear. I guess I should have mentioned that. But here you go. 30 degrees, pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3, and 90 degrees is pi over 2. Now, depending on how you are progressing, you might have professors that want you to like memorize all of the other versions of these, like 150 and why is math so hard right now? 180, 120, and 135, and 180, and then so these are all like second quadrant. And then they'll have you memorize the third quadrant ones, and then the fourth quadrant ones. So like I think like this 3 pi over 4, that's a second quadrant. And that's okay. So, and 5 pi over 6 is also a second quadrant. And there's a second quadrant. I think so I gave you first and second quadrant ones here. But for the moment, go easy on yourself. If you can memorize the first quadrant ones, then the second and third and fourth quadrants are not too terribly bad once you kind of get the pattern. But step 1, memorize the first quadrant. So as soon as you see 30 degrees, your brain should go pi over 6. As soon as you see 60 degrees, your brains go pi over 3. 45 is pi over 4. 90 is pi over 2. Again, something that can help is to take a picture of your notes that says something like this and make it a background on your phone so that every time you pick up your phone, you see this and you're like, oh, this is dumb. I don't want to do this. And then you're like, but now I know it. So memorize these so that you have them, because from now until eternity in STEM classes and in general, people are going to assume that you know what these are and you have to look them up. People are going to make fun of you. So, if you don't want people to make fun of you about your radian degree conversions, memorize these so you'll look cool. Okay, that was great.